Alma has just completed its 10th orbit around the Sun. On March 13, 2013, the Atacama Large Millimeter Submillimeter Array was inaugurated with guests and greetings from everywhere.
We congratulate the scientific communities of North America and Europe and East Asia on today's achievement.
It was a dream come true for the global astronomical community. Astronomers need powerful instruments that can see through dust and gas in the universe and enable human beings to solve cosmic mysteries about cosmic origins.
When was the universe created?
When were the first stars and galaxies born?
How are planets formed?
When did life emerge on Earth?
Is there life elsewhere in the cosmos?
Alma began to observe some of the weakest signals at millimeter and submillimeter wavelengths from cold, dark, and distant objects. Over this first decade, it has made incredible discoveries possible. New observations of young solar systems in formation have revolutionized our understanding of planets' formation. The first detections of complex organic molecules gave us clues about how life could rise elsewhere in the universe. Furthermore, Alma played a crucial role in capturing the first image of a black hole in a global endeavor that gave the world an iconic image. To commemorate these 10 years of successful international collaboration, we invited everyone to celebrate with Alma by sending their greetings and questions.
Hello, Alma. Konnichiwa. Hola, Alma. Hi, Alma. My name is Maya. Hola, Alma. Quería saludarle.
Quise desearle a Alma desde Perú.
Ik ben Milan en ik woon in België. Soms is het moeilijk om in een grote groep te werken. Hoe slagen jullie erin om met al die landen tot overeenkomst te geraken? Dat was mijn vraag.
It took time. In the 80s and 90s, the astronomical communities of Europe, North America, and East Asia worked on 3 projects to build giant submillimeter telescopes separately. By fortune, they realized they could only achieve their needs through a global partnership. Because of this scientific diplomacy, which today unites 21 partner countries in collaboration with Chile, it was possible to build the most powerful radio telescope in history. Alma is jointly operated by the National Radio Astronomy Observatory, managed by associated universities, by the European Southern Observatory, and by the National Astronomical Observatory of Japan. But many other partner institutions were involved in making Alma a reality. Today, the observatory operates 24/7 to provide outstanding data to astronomers worldwide, and it is the strength of the Alma partnership that has enabled everything achieved to date.
Hola, mi nombre es Nicolás, vivo en Coyhaique, al sur de Chile. Mi pregunta es, ¿han pensado alguna vez instalar un observatorio como Alma acá en el sur?
It would be fantastic if our antennas could travel worldwide. However, the truth is that Alma only works on very high plains and an arid climate because the water vapor distorts and weakens the already weak signals that we pick up from the universe. We searched the world for the perfect place until finally settling on the ideal location: the Chantnantor Plateau in the Chilean Atacama Desert.
I'm Callie McPherson from Lee, New Hampshire in the United States. I heard that Alma is 5,000 meters above sea level. How do you work at such high altitudes?
Although this is the perfect place for the Alma antennas, it is far from ideal for humans because of the lack of oxygen, strong winds, and low temperatures. Fortunately, we found solutions so our team could work at a lower altitude. A support facility was built at an altitude of 2,900 meters. There, the parts coming from different countries were assembled into Alma antennas. 25 were manufactured in the United States, another 25 in Europe, and 16 in Japan. But then we had to transport the antennas, which weigh 100 tons each, up the steep road to Chantnantor. For this purpose, 2 unique transporter trucks in the world were built, named Otto and Lore. In 2009, the first antenna reached its final destination. And 2 years later, Alma started science observations with just a quarter of its antennas.
生日快乐！我叫张馨玉，想多认识这些大天线怎么运作。
Alma uses 66 antennas that work together as though they were all small parts of a giant eye with a diameter of up to 16 kilometers. Each antenna has a set of very sensitive receivers that capture the weak waves from the universe and convert them into a digital signal. The correlator, the brain of Alma, was built to process them, an extraordinary supercomputer without precedence that integrates in real time the signals it receives from the 66 antennas, giving it a sharp vision capable of revealing objects never seen before.
この天文台を私たち人類の起源というものを探っていると思いますが、アルマはこの天文台と何が違うのですか?
Alma is one of the best tools today to observe the formation of stars, galaxies, and planets. And it is also complemented by other observatories that provide different data and aspects that allow more scientific advances to be achieved. In 2018, a scientific team used Alma to successfully detect oxygen in one of the most remote galaxies ever observed. This was the farthest trace of oxygen ever found, which is important because its presence means it was formed by very early stars. This finding determined that the birth of stars in this galaxy began only 250 million years after the Big Bang. With these kinds of observations, Alma is helping us unravel the history of our universe.
Hello, Alma. My name is Milan, and I live in Montreal, Canada. My question is, have you found dinosaurs on other planets in the universe? Merci.
We haven't seen dinosaurs, but we have detected planets. Until recently, we didn't know whether these existed outside the solar system. But more than 5,000 exoplanets have already been found. There was another surprise in the constellation of Taurus, where Alma observed the protoplanetary disk around the young star HL Tauri. A protoplanetary disk is a disk-shaped area of gas and dust surrounding young stars where planets are born. The image of HL Tauri exceeded all expectations because it was the sharpest image ever achieved of a planet-forming disk. Its details surprised the astronomic community because they challenged pre-existing ideas about planet formation, and some theories had to be reconsidered. Astronomers have continued to study various protoplanetary disks in different shapes and sizes. And for the first time ever, we observed a forming moon.
Hola, soy Sandra Vallejo y vivo en San Pedro de Atacama. Y me gustaría saber cómo se relaciona el proyecto Alma con Chile.
Chile is part of the Alma partnership. As our host country, it provides access to the most pristine skies in the world. 85% of our workforce is local, including engineers, technicians, and other highly specialized professionals who make our operations possible. On the other hand, the presence of Alma and other observatories has allowed the country to promote the development of its astronomical community, which has guaranteed access to 10% of observation time at Alma. They also have direct contributions because Alma operates a fund for the development of astronomy in Chile and has become a transfer vector for knowledge and technology in different ways. Because of its skies, people, and scientific cooperation, Chile is positioned as a global astronomical capital. In the Antofagasta region, where Alma is located, we have also supported different local initiatives through a special fund. One of our emblematic projects has been a science education program for the students of Toconao, our closest neighbors, whose public school was recognized as one of the top 100 in Chile. And one of its students has already chosen to study astronomy.
My name is Amaya, and I'm from the United States, and I wanted to know more about the first photo taken of the black hole, and if it is true that maybe one day it could swallow us.
We are safe. The black hole is far away. That is why it was such a challenge to capture that image. Black holes were predicted a century ago, but nobody had ever seen one despite being widely studied. They have such a strong gravitational pull that not even light can escape them. This is why the global astronomical community set out to take a photo of one in radio waves. A project named Event Horizon Telescope was created. which used 8 observatories located in different parts of the world, including Alma, to work together to form a single radio telescope of almost the size of the Earth. The first black hole chosen for observation is located in the center of the M87 galaxy. It has a mass equivalent to 6.5 billion times the mass of our Sun. Thanks to a significant collaborative effort and years of work, in 2019, humankind could finally see the first image of a black hole, which was actually its shadow. And 3 years later, the same project published a new picture, this time of the Sagittarius A star, a black hole at the center of our own Milky Way galaxy. Alma was vital in achieving these feats as it is the most sensitive observatory in the entire complex, helping to study objects that have captivated the world for a long time.
Je m'appelle Philippe et je suis français. Je veux savoir si c'est vrai que Alma a fermé pendant la pandémie.
Yes. At the beginning of 2020, the global COVID pandemic forced us to pause our search for our cosmic origins for the first time ever. Our team had to go home. The antennas were stopped, and our facilities remained empty. It was challenging, but thanks to team's resilience and excellent work, we started awakening the giant 6 months later.
Atenta control, móvil Z27, subiendo por el 21. Antena de A48 energizada. Muchas gracias.
And exactly 1 year after shutting down, we could finally resume our exploration of the universe. We are very excited too. The future will also be challenging because Alma's technology must remain at the forefront. Projects will be carried out over the next decade to increase the observatory's performance and efficiency. We will expand the bandwidth and install a new digital transmission system, a 2.0 correlator, and an updated processing system. With this, we can generate more data than we do now, making it possible to complete in just 1 week of observations that take more than a year today. We will be able to study not just one, but dozens of molecules in distant galaxies and collect details of how gas and dust move in protoplanetary disks with incredible precision and at much greater distances than today. We are looking forward to what Alma can do in the future. We are proud of what we have achieved over this first decade. We thank those who are and have been part of this project. People from different countries, cultures, professions, and backgrounds from across the Alma partnership and beyond, united in the search for answers to the fundamental questions of our existence. Where do we come from, and where are we going? Thank you for joining Alma in the curiosity to understand our cosmic origins. And please stay with us on this adventure.
Happy 10th anniversary! Alma.
Bon anniversaire, Alma!
Felices 10 años. Sí.
Que sigan los éxitos. Les enviamos un saludo.
Happy birthday, Alma!
Cumpleaños, Alma.
Alma, 10周年おめでとうございます。
¡Feliz cumpleaños, Alma!
Y que sigan cumpliendo muchos años más.